Section 1. Understanding sampling distributions, the basics. Imagine baking a batch of your favorite cookies. You wouldn't eat the entire batch at once, or maybe you would, but let's pretend you wouldn't. Instead, you'd take a few cookies to get a taste. In statistics, we do something similar. Instead of studying an entire population, we take a smaller group called a sample. Now, what if we took multiple samples and calculated the average of each sample? That's where sampling distributions come in. A sampling distribution is like a special collection of these averages. It's a distribution of a statistic, like the average or mean, calculated from many different samples of the same size taken from the same population. It's a theoretical concept that helps us understand how much our sample statistics are likely to vary from the true population parameter. Sampling distributions are the behind-the-scenes heroes of the statistics world. They might seem a bit abstract at first, but they are essential for making inferences about populations based on sample data. Section 2. The purpose and power of sampling distributions. Why do we even bother with sampling distributions? Well, they are crucial for one key reason. They help us estimate population parameters. Let's say we want to know the average height of all women in a country. It's impractical to measure the height of every single woman. So we take a random sample of women, calculate their average height, and use that as an estimate of the population mean. But how reliable is this estimate? That's where sampling distributions come in. By looking at the distribution of sample means from many different samples, we can get a sense of how much variation we can expect. If the distribution is tightly clustered around the true population mean, our estimate is likely to be quite accurate. But if the distribution is widely spread out, our estimate might be less reliable. Sampling distributions give us a way to quantify this uncertainty and calculate the probability of getting a sample mean that's far from the true population mean. They allow us to make statistical inferences such as confidence intervals and hypothesis tests, which are essential tools for scientific research, business decision-making, and many other fields. Section 3. Key characteristics. Unraveling the secrets of sampling distributions. Like any distribution, sampling distributions have certain characteristics that define their shape and behavior. Understanding these characteristics is key to interpreting and using sampling distributions effectively. Let's explore 3 key characteristics. Shape. One of the most important characteristics of a sampling distribution is its shape. In many cases, sampling distributions tend to be normally distributed, especially when the sample size is large. This bell-shaped curve is a statistician's best friend because it makes many calculations and inferences much easier. The mean of a sampling distribution, also known as the expected value, tells us the average value of the statistic, like the sample mean, we would expect to get if we took an infinite number of samples from the population. A key point here is that the mean of the sampling distribution is equal to the population parameter we are trying to estimate. Standard deviation. The standard deviation of a sampling distribution, also known as the standard error, measures the spread or variability of the sample statistics. A smaller standard error indicates that the sample statistics are tightly clustered around the population parameter, while a larger standard error indicates more variability. Understanding these characteristics helps us determine how reliable our sample statistics are as estimates of the population parameters. Section 4. The importance of sampling distributions, a cornerstone of statistical analysis. Sampling distributions are not just theoretical concepts, they are the backbone of statistical inference. They allow us to move beyond simply describing our sample data and make generalizations about the larger population from which the sample was drawn. Without sampling distributions, we would be stuck in a world of uncertainty, unable to draw meaningful conclusions from our data. We wouldn't be able to conduct hypothesis tests, estimate population parameters with confidence, or make informed decisions based on statistical evidence. In essence, sampling distributions bridge the gap between our sample data and the populations we want to understand. They are a testament to the power of statistical thinking and the elegance of using probability theory to make sense of the world around us.